little while back, good heavens.
Sorry about that.
All right, got it. A while back, I needed a power supply to drive a little spindle motor on a little XY cutter that I have here for mostly wood and plastic, but needed slow speeds for plastic so I didn't melt things rather than cut them. And so I was looking around for a power supply that was variable, didn't have one handy, and got to thinking, well, what can I do with what I've got? And I discovered that I had a bunch of old computer power supplies. So looked into them and see what I could do. So let's see if the magic works here. I'll try to bring all this stuff up. Theoretically, we may be in a position to go with this. Yes. Okay, so computer power supplies could be a good source for getting low voltage DC at fairly high currents for whatever you need around there. Got to thinking maybe a variable bench supply might be a good solution. So I looked at what I had. I've got an old one from a very old computer that ran only had the yellow and the red wires, the 12 volt and the 5 volt coming out. But everybody probably has got several of these kicking around, and some more than others. Get them at a ham fest for a pretty low dollar. So we'll see what we can learn about these things. One, they all use a switching power supply internally. And many, especially the older ones, use this little TI chip called the TL494, which is nothing more than an inverter that drives pulses out to a switching transistor. And the pulse width that it drives out to these switching transistors is regulated by a voltage signal comes in on pin 1. The voltage signal is compared to a comparison which comes off of a reference voltage, Vref, comes in here. And if the voltage is higher than Vref, then it narrows down the pulses, puts less energy across the transformer into this output circuit. If it's lower than reference, it makes the pulses wider. So what it does is it tries to maintain a constant voltage out here on the output, which is measured by a voltage divider, in this case 22K against 4.7K, from the output rail to ground. So if you can get a hold of this pin 1 point, which is the point that it tries to regulate to, you might be able to do some good things with this. So the idea is you take your 494 and feed pin 1 from your own voltage divider, blow away what's in the power supply, and drive the pin 1 point from a wiper on a pot. So now theoretically you've got an adjustable power supply here. And if you put it together, by golly, it seems to work. So pin 1. Okay, here's what the power supply board looks like. A couple of heat sinks, a couple of chips. This is the TL494 chip here. The end with the notch is the starting point. Pin 1 would be this point here. So you have to get to him to have any chance of doing some useful changes to the power supply. Output circuit, basically filters, capacitors here, switching transistors on this heat sink. No, the rectifiers for the output are on the heat sink. The switching transistors are on the input heat sink that comes off of a regulator filter. And the transformer that isolates the input from the output is in between here. So pin 1 is our key, and that's the guy we need to get after. And if you flip the board over, and find pin 1, you can put a wire on there that runs over to the wiper on your pot that we showed on the circuit earlier, but you have to isolate the trace that was originally from the voltage divider that was for the fixed ratio. And here the isolation is done with just a little bit of cutting on the trace, and that's all it takes is to get a hold of this guy and make it useful. One of the things that you have to do on a lot of the older supplies, and maybe even on some of the newer ones, is you have to put a load on. And typically these things like to have the 5-volt circuit loaded at least to 1 amp or so. That stabilizes the regulation that it does. Elsewise, the pulse width kind of gets really weird, especially at the narrow ranges. So just hung a 5 ohm resistor, clipped it with a piece of aluminum to the heatsink, and ran that over to the 5-volt supply. Seemed to be pretty happy to have something like that on there, and the voltage is stabilized. So I turned around and made a little control panel for this thing where I could have a pot where I could adjust the voltage. And then found one of these little $3 voltmeters, a couple of LEDs, assembled it with adhesive systems, which means I glued it in place, and put a switch here because I wanted to switch both between the 12-volt line that I was going to be regulating to and also the 5-volt line to see what it was coming out at, because the 12 and 5 track together. So you raise one, the other raises as well, and vice versa. So found a little old plastic box that had been used for something else, cut some space in it for the parts that I was adding, glued it all together, and there's the power supply. Here's our power supply, the guy with the 5 ohm resistor in here. The red and yellow wires, which are the 12-volt, original 12-volt and original 5-volt outputs, were brought out to a terminal strip. 12 volts ground, 5 volts ground, and then an earth ground there. And the little three element, 3-digit voltmeter mounted on the front of the panel with the pot and a switch that was going to select between this, the 12-volt or the original 5-volt line, to see what kind of output voltage I was getting. I did some testing with this, and this power supply was rated at something like 10 to 12 amps on 12 volts. And the loads that I had easily could go up to 6 amps on the 12-volt line, which I ran, and found out that at 12 volts, say, dialed up some voltage, 13.8, and it didn't change much on the display, maybe 1 digit. If you put a voltmeter on here and measured it out to a higher precision, about 20 millivolts from 0 load to 6 amps load was the only change we got. It was about 20 millivolts. So this is a good regulated power supply, all done with just that pin 1 modification on an old computer power supply. Here it is, all closed up, labeled up. You can see the output terminals a little better here, dialed down to 10 volts here. Switch between high and low voltage that's being monitored. And then guess since the thing worked and closed up and played nicely at 6 amps, which was enough for what I needed, well, by golly, I went ahead and put some labels on it. So here's my high voltage output, ground, low voltage output, it's ground. Switch, high, turned out to be 5 to 15 for stability, and low, 1 to 5. So switching between the two lines, I could dial up any voltage I wanted, basically from 1 to 15. Any questions? Okay, this is it. This takes a little bit of internal modification, get in there, work on the board, modify the power supply to make it work, put on whatever control you think you need for your uses. And that's simple. There's probably, I don't know, $3, $5, $7 Oh, and the resistor's another buck. Say there's about $12 worth of parts in here to make a variable supply that gives you 1 to 15 volts at up to 6 amps
Ernie, I have a,
or higher. Go ahead.
if you tried to,
Yeah,
if you load it up to say 3 or 4 amps at the higher voltage, do you have any thermal issues?
no, there's a fan in the back of the power supply, and I reversed the fan because I closed this didn't fully block. I didn't fully block the vents on this end,
Right.
but to make sure I had good airflow on the heat sinks, I turned the fan around so it blows cold air into the heat sinks rather than try to draw cool air across them. So that's it. I mean, this is a nice little power bench supply. If you had to buy the parts, like I said, I'm 10 to 12 bucks and you're in business. Fortunately, my junk boxes are very large and I didn't have any trouble finding what I needed in there. Now, if you want to do something a little simpler, especially if you're using one of the new ATX power supplies that's got a whole gamut of voltages coming out for the new motherboards, you can break down and spend about $8 to $12 also on a breakout board, terminal strip, terminal binding posts here, fuses, and a connector that marries up with all the ATX type power supplies. Just plug one in here, plug it in the wall, and off you go. You got 5 amps at all these different voltages, including minus 12 if you want to do op amp or analog things where you need plus and minus 12. The other voltages, of course, being 5 and 3.3. It's a nifty little gadget for breaking out and hooked to an ATX supply with a big fat pigtail of wires. Uh, Looks like that. Is handy. You can put it on the bench and you get the most common power supplies power supply voltages that you may need. And this again is in the $10 to $12 range to get you in business, not counting the supply cost itself, which may vary from anywhere from, oh, I don't know, $5, I guess, is pretty high for Hamfest price for these things. Some places you go and the guy will give you $2 if you take it off his hands. So that's that. Alternatively, if you just want to spend some money, you can buy a little box from China, 0 to 30 volts, up to 10 amps supply, nice digital readouts, not guaranteed to be very precise, but usable. And something like this is currently available for about 50 bucks, including shipping. So that's it for power supplies. Those are your choices, at least as far as I'm concerned, for doing it on the low budget. And what else have we got? We've got, yeah, there's at least one less power supply in the pile now. Any questions? Thank
Arnie,
you.
what is your? I have almost the exact same use case. I need to drive a motor to uh, turn a spud for a grinding application. What size motor are you driving with this thing?
I'm currently using what it is a drill motor, a geared drill motor from a 12 volt drill
Okay,
that came there. And my concern was to run slow enough so that I can cut plastic and not melt it.
right, right. Yeah,
But
and
well, you can run up if you look at it from that point. Say you can get 10 amps out of one of these 12 amp or larger power supplies on 12 volts, and you crank it up to say 15 at 10 amps. Don't load the 5 volt leg any more than the 1 amp resistor or something on it. Uh, because they both share the same transformer, so there's a certain amount of wattage that the power supply can deliver. The current limiting will probably be the size of the windings, the 12 volt windings on the transformer, the wire size. But if you can get, say, 10 amps out of one of those things at 15 volts, that's 150 watts which for a spindle motor, well,
Well,
depending
and
on what you're cutting
yeah,
and
I'm
what you're
not looking
grinding.
I'm not looking for the grinding spindle. I'm looking for the tool spindle. So it's basically turning an arbor so that the part is turning while the grinding wheel is hitting it. So it's a pretty
Oh, okay, okay. So that,
low
yeah,
speed,
that
low
load
load.
will be, yeah, it'll be variable depending on how hard you hit it with the grinding tool
Right,
itself.
right, right.
Well,
But no, that's a
all I can
cool.
say is experiment.
Yeah, no, I was wondering what you were using for a motor and stuff. That's a pretty good idea. I like that.
Yeah, well, there's a lot of, especially these days with the 18 and 20 volt drills coming popular. There's a bunch of the old 12 volt drills available at very low prices.
Right.
And a lot of them, when you pull them out of the case, are quite usable. The one issue with a lot of those, but your application may not need it too much, is that the equivalent of the spindle bearing on coming out of either the gear motor or out of the motor itself may not be very stable. It may have run out that
Right.
if you're trying to do some precision work, trying to keep the tool in the same place, the run out may bother you.
Yeah, yeah. No, I would just be doing a pulley to another pulley. All the precision would be
Okay,
in the
yeah, and then you
fixture.
can have a good spindle on the thing to hold everything in place.
Excellent. That's a great idea. Thank you.
Any other questions?
Going back to, plan design number one, where you're, going off and changing the reference voltage.
Yeah, I
You're
can go
talking
back to that
about, what
circuit
about
if you like.
but I mean, you're looking at multiple, that guy, whoa. Okay, so there you're looking at what, about a 30K linear taper pot? It doesn't have to
Well,
be,
actually, as a matter of fact, I used a 10K here,
oh,
and
okay,
turned out that I needed a 5K offset here to keep this voltage from getting too low in here and driving this guy crazy because it's dropped way below the reference voltage, which is V ref here is 5 volts nominally. And it
okay,
wants to be very close to that because that's where it's going to try to regulate to.
okay. And this particular thing, at least design number one, you're talking about something that can do variable voltage, whereas your ATX breakout is a good solution if you're looking for,
Yeah,
doing some work with digital circuits.
if you can get by with those voltages for what you're doing, it's a nice, easy way to get there. This one, like I said, you got to get in here and do a little diddling, little trace cutting, and things like that.
Any RF spectrum
I
issues?
tried to use. Say again.
Or have you looked at any RF issues? Like what does the noise spectrum look like?
Well, the regulator, the regulator's chip is running at the same frequency that it always did. And the filtering here is set up to nominally knock that frequency out of the output. So there was no change in that. So this thing is as good as it was when it came out of the computer, and all the FCC type whatever numbers were theoretically met.
Yeah, I'm not sure that's adequate for being close to an HF station, but maybe.
What's an HF station again?
A high frequency ham station.
And what do you do with that?
Well, that's just for, the 20 meter, 80 meter. You talk to the world, Arnie.
I was going to say, what does Bob do with it, or what does Arnie do with it?
Yeah, exactly. Yeah, that's no. This is a bench supply when you're not operating HF or not operating on the ham frequencies, but you're in the back room rebuilding something or modifying something, and you need some power to do that. This is when this guy is turned on and used.
So
I don't know that I'd use it for powering a radio, but you probably could. you might need to put some ferrites, donuts on the output leads when you get them out of here,
Right.
just to knock the edges off again.
So a few years ago, I was trying to power an SDR that ran at 5 volts, and it came with a wall wart, and it was pretty bad. I was at Haltech in Silicon Valley and bought different brands of wall warts and loaded them up to about 2 amps. And I had at the time a Tektronix scope that had a DFT in it that I could look at the spectrum. I mean, I'll tell you, the GRUD at 60 kilohertz was terrible. It was so bad that I just abandoned the idea, and I went online and found a Sola linear control system supplied for about $8 that would do
Excellent.
well more than enough current I needed. I should have brought it in, but I then found an enclosure and packaged it up like you did. I don't have a voltmeter, but the idea is it doesn't make noise.
Yeah, the Sola ferroresonant type regulator was actually a pretty clever design because it used a special transformer with special air gaps and things like that, and was resonant at 60 hertz or wherever it was designed for, and it did a real good job of giving a clean sine wave output and regulating the AC voltage to the line voltage you wanted.
Right.
Any other questions? Okay, let's see if we can figure out how to get out of here.
Well done. Thank you, Arnie.
All right, that's it. Next.
Well, that's cool. I appreciate it. Yeah, I actually, like I said, I actually have a real use case coming up for that. So I will definitely, I might have to harass you. Although I know someone that probably has a pretty good junk box to come up with some parts as well. So
Do you need variable voltage, or can you live with 12 volts?
no, I prefer variable.
Okay.
Yeah.
Yeah, then we'll have to tear in there and get a hold of the regulator point and diddle it.
Yep. Yep. We can make that work. Well, thank you, Arnie. I'm gonna